Example 17. In a probability experiment, 3 containers have the following contents. There is a jar that contains 2 white dice and 3 black dice. There is a white box that contains 5 red balls and 3 green balls. A black box that contains 4 red balls and 3 green balls. A die is taken at random from the jar. If the die is white, 2 balls are taken from the white box at random and without replacement. If the die is black, 2 balls are taken from the black box at random and without replacement. The events W and M are defined as follows. W is that a white die is taken from the jar, and M is that 1 red ball and 1 green ball are obtained. Whereas to show that the probability of obtaining 1 red ball and 1 green ball, given that a white die is taken from the jar, is 15 upon 28. So that's the first part. This type of question is quite long and sometimes a little bit difficult to get a grasp on. So the first thing that I want to do before I even try to solve it is I want to sketch a picture of it. That is, I want to look at the probability tree diagram. So right at the onset, what do we have? We've got 2 possibilities. We've got either a white die is drawn or a white die is not drawn, W prime. Well, what's the chance of a white die being drawn? There are 2 white die and 3 black die, so there are 5 die in total, 2 of which are white. There's a 2 over 5 chance of a white die being drawn and a 3 over 5 chance of a black die being drawn. If a white die is drawn, we go to the white box. Now, each time we go into the white box twice then, and we pull out 2 balls. So, there are 2 possibilities. Either we get a red ball, or we get a green ball. There are 5 red balls and 3 green balls. That means on the first draw, there's a 5 over 8 chance of getting a red ball, and a 3 over 8 chance of getting a green ball. What about on the second draw, where we also go back to the same box without replacement? Well, now there are only 7 balls remaining. If a red ball was drawn first, 4 of those 7 are red, and 3 of those 7 are green. If a green ball was drawn first, then 5 of those 7 are red, and 2 of those 7 are green. And we can do the same thing for what happens if we drew a black dice, because if we draw a black dice, we go to the black box. Sorry, that should be green, not red. And there are 4 red balls and 3 green balls. That means there's a 4 over 7 chance of drawing a red and a 3 over 7 chance of drawing a green. What about for the second draw? Now there are only 6 left. This would be 3 upon 6 because there'd be 3 red balls left out of the 6. And this would still be 3 green balls left, 6 balls left. What happens if I drew a green first? Then there are 4 red balls left out of the 6 balls. And if I drew a green first, there would now be 2 greens left amongst the 6. So this is my probability tree diagram. This helps me get a bit more of a handle on the way the probabilities work out. I'm asked to find the probability of M given W. Sorry, hold on, what's happened here? Probability of M given W. Given W means I only need to pay attention to this branch on my tree diagram. So I'm only going to pay attention to these possible outcomes. Right? It means that given that I drew a white the first time, I didn't draw a black die, I drew a white die. Now what's the chance that event M happens? Well, what is event M? Event M is that I get 1 red ball and 1 green ball. That means I either end up with this outcome or this outcome. Now, because these outcomes are not equally likely, I need to go through and calculate the probability of each happening. So, what is the probability of this first one happening? This would be 2 over 5 times 5 over 8 times 4 over 7. What's the chance of the second one? That would be 2 over 5 times 5 over 8 times 3 over 7. The third one would be 2 over 5 times 3 over 8 times 5 over 7. And the fourth one would be 2 over 5 times 3 over 8 times 2 over 7. Okay? So actually, if I add all these up, it should be quite clear that I'm going to get 2/5, which would just be the chance of me drawing a white ball at the start. Then the two that I want are these two. So this is that I draw a white ball at the start and I end up with one green ball and one red ball. So let's go back to our working. Let's go back to our problem. How do we present this? The solution. The probability that I get one ball of each colour, given I drew a white die at first, is going to be the probability that I get one ball of each colour and drew a white die first, divided by the probability that I drew a white die. What's that going to be? Well, we already just saw these two are the probability of drawing a white die first and getting a ball of each colour. So this top line is 2 over 5 times 5 over 8 times 3 over 7, or, so this is the chance of going white die, red ball, green ball, divided by 2 over 5 times, instead of getting a red ball now I get a green ball, 3 over 8 times, now I get a red ball, 5 over 7. The whole thing is divided by 2 upon 5. And the answer, when you plug that into your calculator, comes out to be 15 over 28. So that's what we wanted to show. For the next part, we need to find the following, giving each of our answers as a fraction. So the first thing I need to find is I need to find the probability that I get a ball of each colour and I draw a white die first. Well, we've actually already worked this out. That's going to just be the top line over here. So what is that? That is 2 upon 5 times 5 upon 8 times 3 upon 7 plus 2 upon 5 times 3 upon 8 times 5 upon 7. And that turns out to be 3 upon 14. Part 2, I'm asked to find the probability of W given M. So this is the probability of W and M divided by the probability of M this time. So we've just worked out the probability of W and M, that's 3 over 14. What's the probability of getting one ball of each colour? Let's go back to our diagram. This time, how could I get one of each colour? Let me erase this. Well, I can go this way, or this way, or this way, or this way. So I need to work out these probabilities. So you can just read them off, and we'll do just that. So the bottom line here is 2 over 5 times 5 over 8 times 3 over 7. That goes white, red, green, plus 2 over 5, 3 over 8, 5 over 7, that's white, green, red, plus 3 over 5, 4 over 7, 3 over 6, sorry, this is black, red, green, plus 3 over 5, 3 over 7, 4 over 6, and this is black, green, red. So I'm sorry that's a little bit messy. What happens when you actually plug in the numbers and do the calculations, you come out with the number 5 upon 13. Part 3 wants us to work out the probability of W happening, so a white die being drawn, or one of each colours being drawn from the two balls. Well, we know what this is. We know that this is just going to be the probability that W is drawn, plus the probability that we get one of each ball, coloured balls, minus the probability that they both happen. And we actually have all of these probabilities. The probability of W is easy enough, that's just 2 over 5. The probability of one of each coloured ball being drawn, this is just the bottom line over here. This is what we were working out earlier, right? So if we go back and do our calculations again, we find that that comes out to be 39 over 70. And then, sorry, minus the last one. Then I have to minus away the probability that they both happen. I worked that out earlier as well. That is 3 upon 14. And so at the end of the day, the number we get is 26 upon 35. The last part now tells us that all of the balls are being replaced into a single container along with the dice, and 4 objects are taken at random, each object being replaced before the next one is taken. We have to find the probability that one object of each colour is obtained. Well, that's a little bit tricky to do, but I'm going to do something a little bit easier. What's the probability that I first get a white dice, then a black dice, then a red ball, then a green ball? Well, that's going to be 2 upon 20 times, because it's with replacement, 3 upon 20, 3 black dice, 20 items in the box, times 9 upon 20, 9 red balls, 20 items in the box, times 6 upon 20, 6 green balls, 20 items in the box. So that's all well and good. Then how do I find the chance that I get one of each colour? Well, if I get one of each colour, it has to be a permutation of this. Now, all permutations of this are equally likely. That is, it doesn't matter which order I'm drawing it in, because it's with replacement, the probabilities of drawing a white is the same. It's independent, so it can happen at any time. So there's only, each way is equally likely. So I just need to count the number of possible permutations I have for these 4 objects. And I know how to do that from P&C. So the probability of one object of each colour is just going to be the probability of getting white, blue, red, green, times the number of ways I can arrange those 4, which is 4 factorial. And that works out to be 243 divided by 5,000.